Welcome to Code Craft, Mastering Python Functions. Have you ever found yourself writing the same block of code multiple times? Copy-pasting isn't just tedious, it's a fast track to bugs and unmanageable code. Today, we're diving deep into one of Python's most fundamental and powerful concepts, functions. Functions are the building blocks of clean, reusable, and maintainable code. They allow you to encapsulate a specific task, give it a name, and then execute it whenever you need, without rewriting it. Imagine them as mini-programs within your main program, designed to perform a single, well-defined job. Whether you're a seasoned software engineer or an aspiring IT student, understanding functions is crucial for writing efficient and professional Python applications. We'll explore how to define them, pass data into them using parameters, retrieve results with return values, and even handle flexible numbers of inputs. Get ready to transform your Python coding style from repetitive to professional. We'll be using a practical project called Python Pro to demonstrate these concepts hands-on, so you can follow along and experiment yourself. Let's get started. At its core, a function is a named block of code that performs a specific task. Think of it like a specialized machine in a factory. You feed it raw materials, inputs, it does its work, and then it produces an output. In Python, we define a function using the def keyword, followed by the function name, parentheses, and a colon. The code block belonging to the function is indented. This indentation is super important in Python. It tells the interpreter what statements are part of the function. For example, if you want to create a function that simply says hello, you'd start with def say_hello. Inside the function, you'd place your print, hello statement, indented. This simple structure is the foundation of all functions, no matter how complex they become. They help break down complex problems into smaller, manageable chunks, making your code easier to write, read, and debug. This modularity is a game changer for larger projects, promoting collaboration and reducing errors. Now, how do we get information into our functions? That's where parameters come in. Parameters are placeholders for the data a function needs to perform its task. When you call a function, you provide actual values, known as arguments, which are then assigned to these parameters. Let's look at a concrete example from our Python Pro project, specifically src/calculator.py. You'll find a function there called add, defined as def add a, b. Here, a and b are parameters. When you call add 10, 5, in src/main.py, 10 is passed as the argument for a, and 5 for b. These are known as positional arguments because their position in the function call determines which parameter they map to. Parameters make your functions versatile. Instead of writing separate functions for adding different sets of numbers, you write one add function that can work with any two numbers you provide. This reusability is key to efficient programming. Just as we pass information into functions using parameters, functions often need to send information back out. This is achieved with the return statement. The return statement specifies the value that a function sends back to the part of the code that called it. Once a return statement is executed, the function immediately terminates, and the returned value is passed back. In our add a, b example, the line return a plus b calculates the sum of a and b and then sends that result back. So, when main.py calls result_add equals add 10, 5, the value 15 is returned by the add function and stored in the result_add variable. Without a return statement, a Python function implicitly returns none. Returning values allows functions to produce results that can then be used in further calculations, displayed to the user, or processed by other parts of your program, making them truly powerful computational units. Python functions offer even more flexibility with default parameters. These allow you to define a default value for a parameter, which will be used if no argument is provided for that parameter during the function call. This is incredibly useful for creating functions that are versatile but also have sensible defaults. Consider the multiply, x, y equals 2, function in calculator.py. Here, y has a default value of 2. If you call multiply, 7, x will be 7, and y will automatically take its default value of 2, resulting in 14. However, you can always override the default. If you call multiply, 7, 3, y will now be 3, and the result will be 21. Our greet, name equals guest, message equals hello function takes this a step further, demonstrating multiple default parameters. This feature simplifies function calls, especially when many parameters are optional, allowing developers to omit arguments for common use cases while retaining the ability to customize behavior when needed. It promotes cleaner code and reduces the need for multiple overloaded functions for slightly different scenarios. What if you don't know exactly how many arguments a function might receive? Python's *arg syntax comes to the rescue. The ** before a parameter name in a function definition allows the function to accept an arbitrary number of positional arguments. These arguments are then collected into a tuple inside the function. Look at calculate_average, * numbers, in our calculator.py file. When you call calculate_average, 10, 20, or calculate_average, 1, 2, 3, 4, 5, all those numbers are packed into a tuple called numbers within the function. This enables calculate_average to compute the average of any number of values you pass to it, from 2 to 200, without needing to define a new parameter for each. It's perfect for functions that operate on collections of data where the size of the collection isn't fixed beforehand, providing a flexible and robust way to handle varying inputs. While *args handles an arbitrary number of positional arguments, **quargs, short for keyword arguments, allows a function to accept an arbitrary number of keyword arguments. The double *** before a parameter name collects all past keyword arguments into a dictionary. This means you can pass arguments like name equals John, age equals 30, city equals New York, and *** quargs will gather them into a dictionary where keys are the argument names and values are their corresponding values. Our display_info, *** details, function in calculator.py exemplifies this. When main.py calls display_info, name equals John Doe, age equals 30, city equals New York, the details parameter inside the function becomes a dictionary like name, John Doe, age, 30, city, New York. This is incredibly powerful for functions that need to handle flexible, descriptive configuration options or user profiles, where you don't know all possible attributes beforehand. It offers immense flexibility, allowing functions to adapt to diverse data structures. Now that we've seen how to define functions and handle various types of arguments, let's see how they all come together in a larger application. This is where src/main.py comes in. In real-world projects, you rarely put all your functions in one massive file. Instead, you organize them into modules, separate Python files. Calculator.py is our module, containing all our function definitions. Main.py then imports these functions using the from calculator import statement. This modular approach keeps your code organized, readable, and highly reusable. You can reuse the calculator.py module in any other Python script simply by importing it, without copying a single line of code. This separation of concerns, defining functions in one place and using them in another, is a cornerstone of good software engineering practices. It simplifies debugging, makes teams more efficient, and scales beautifully as your projects grow. Let's walk through the execution flow in src/main.py to see these concepts in action. The run_demonstrations function in main.py serves as our orchestrator. It calls each function from calculator.py with different arguments to showcase their behavior. For instance, you'll see result_add equals add, 10, 5, calling our basic addition function, storing its return value. Then there's multiply, 7, using the default parameter, followed by multiply, 7, 3, overriding it. The script then proceeds to demonstrate greet, Alice, and greet, Bob, hi there, illustrating how default parameters provide flexibility. The calculate_average calls show *args collecting numbers, while display_info calls illustrate *** quargs handling key value pairs. Finally, is_even, 4, and is_even, 7, demonstrate a Boolean return. The crucial part here is the if __name __main__, block at the end of main.py. This standard Python idiom ensures that run_demonstrations is only called when main.py is executed directly, not when it's imported as a module into another script. It's a best practice for writing reusable Python code. So, why go through all this trouble to write functions? The benefits are immense. First, reusability, write once, use everywhere. This is the essence of the DRY principle, don't repeat yourself. Second, modularity, functions break down complex problems into smaller, manageable, and